see how long the battery lasts. Right, good evening. We've only looked at really taking derivatives of polynomials and rational functions, right? We start looking at some more interesting functions. Starting with the trig functions. Again, I'm not going to go through the derivations. Read through the book. Derivative of sine is cosine. Derivative of cosine is negative sine. And then tangent, cotangent, secant, and cosecant. So remember, these other four trig functions, you can write them all in terms of sine and cosine. So you can just use the rules that we've already looked at, specifically the quotient rule, to get those derivatives. And you'll find that tangent is secant squared, cotangent is negative cosecant squared, secant is secant tangent, cosecant is negative cosecant cotangent. There you go. There's all 6 trigonometric functions and their derivatives. At the same time, I'm going to look at chain rule. Chain rule gives us a way of finding the derivative of a composition of functions. So you're given a composition, f of g, the derivative, f prime of g of x times g prime of x. Alternatively, using Leibniz notation, dy dx is dy du times du dx. Remember in pre-calc, you spent some time decomposing functions, right? You were given a function, and you're asked to decompose it into f and g. So there was f of g of x. This is one. So you get to the chain rule. This is a strategy introduced. I'm probably different than it. But it doesn't matter. So let's see what it says. Okay, so begin by identifying f of x and g of x. So you want to begin by identifying your outer and inner functions. Oh, by the way, chain rule can extend to nested compositions, right? So f of g of h, so on and so forth. Then evaluate f prime. And so once you have f of x, evaluate f prime of x. Now evaluate f prime at g of x. Right, then you find g prime and multiply. And that's saying what I just mentioned. You can have a nested composition. As a general thumb with chain rule, work your way out. Start in and work your way out. They're saying out in, it doesn't matter, I do it now. So I'll shut off both ways. With the chain rule, we can now introduce the rules previously in their more general form. So for instance, is this the general power rule? Yes. General power rule. d dx of u to the n, u to the n minus 1 times u prime. This is chain rule for if you have 3 functions, composition. So chain rules apply twice. And then the trigonometric derivatives in their general form. And what's that? Oh, that's just the Leibniz notation, which I already went over. And it's probably going to be these general forms that I use the most. We're actually going to derive the derivative of tangent. How can you write tangent in terms of sine and cosine? What is it? What's the quotient rule say? Keep going.
Numerator prime denominator. Numerator prime denominator divided by denominator short.
It sounds like it would just be 0. I think you said the same thing twice.
Numerator prime times denominator minus denominator prime times numerator over denominator squared.
What is the derivative of sine? What's the derivative of cosine? What's cosine squared plus sine squared? How can 1 over cosine be simplified? So 1 over cosine squared squared. Starts off kind of boring. Once we get the chain rule, things are going to pick up. Look at the big picture. What type of function is f?
Polynomial?
Well, it's definitely not a polynomial.
Oh, sorry.
It's a sum of functions, isn't it? Sum rule. What does the sum rule tell you?
Isn't it, when you find them, they're the same?
What do you mean the same?
The sine is just, cosine is just going to be.
So ignore the actual function themselves. If you have the sum of two functions, what does the sum rule say about its derivative?
You just add, you
Add what?
add the two functions, you add the two products, and put together.
Add the two products?
You add,
It's like saying derivative of sums is the sum of the derivative.
Add the two derivatives. So you just differentiate term by term, right? So with that in mind, just look at the first term. And now ask yourself the exact same question. Big picture. What kind of function is that?
Multiplication.
Product of functions, isn't it? So what rule is that?
Product rule.
What does the product rule say? You take the derivative of a product of functions. What do you get?
You get x plus the derivative.
I don't care about
Oh, the actual thing?
Just saying, what is the rule?
I don't know how to word it.
Second times derivative of the first plus first times derivative of the second. So for now, I'm just going to put it in parentheses to signify that what we're working with right now is that first function in the sum. The second is sine of x, right? What is the derivative of x?
One.
1. Plus, first function is x. What's the derivative of the second? So what's the derivative of sine?
Cosine.
Now you move on. So that took care of that one, right? Big picture, what kind of function is that? It's a cosine function, right? So it's the cosine rule. What is the derivative of cosine? Now just simplify. X times cosine of x. Yeah. And that's essentially how you're going to break down every single derivative. It's the easiest way to do it is just look big picture and then work your way down. You've graduated from the calculator, huh? Now the binder that's fallen.
Oh.
We've graduated. Next one's going to be your computer. That won't be good. Well, I hope not. I have a rule: if I have to call for aid, It's costing you. Cost you for the inconvenience.
Okay.
Even worse if I have to testify. If you commit a crime and I have to testify, oh boy. Look, big picture. What kind of function are we dealing with? Which is what? So obviously it's the quotient rule, right? Oh, we just did the quotient rule, right? Denominator times derivative of the numerator. What kind of function is the numerator?
Just sine,
So it's the sine rule, which says derivative of sine is what?
cosine,
Minus numerator times derivative of the denominator. What kind of function is the denominator?
x.
So what kind of function would that be?
Just the number.
It's technically a power function. So power rule. But its derivative is what?
One.
So I don't need it. All over denominator squared. And then is there a way to simplify that?
Yeah, no.
I guess you could divide x squared by both terms. It's not really simple, it just looks different.
Which would be cosine x over x minus sine x over x squared. That doesn't. Yeah, that's not really simplified, but there's a benefit. There are simplifications we can make because there's a lot of trig identities. So I could use a half angle identity if I wanted to. I could actually use a double angle. I could use a reduction if I wanted to. None of them are really beneficial, so we're done. Okay, show this one. How can we write secant of x?
Wait, can we do cosine to the negative one and use like the general power rule?
We could, but that technically comes after these.
Oh,
So I'm not going to, I'm just going to purely use quotient rule here.
okay.
But you could, right? You could write that as cosine all to the minus 1. Be careful how you write it though, because you don't want to write it as the inverse cosine. And then yeah, you chain rule from that.
I think there's a difference between
Wow, that would make things too easy. Quotient rule. Denominator times derivative of the numerator.
The power rule.
What's the derivative of 1?
one never changes.
Minus numerator times derivative of the denominator. So what's the derivative of cosine?
Negative sign.
You're left with sine over cosine squared, right? Except I should probably write it in the other end, whatever. Isn't that the same as sine over cosine times 1 over cosine? What's sine over cosine?
Tangent.
What is 1 over cosine?
Secant. It's sort of a simplification. But
Sure.
it'll be sine secant squared.
Which is tangent secant. Or secant tangent. It's simplified because they're all powers of 1.
Oh, okay.
Right, whereas the last one was sine secant squared, you have that secant squared in there, which you typically don't like.
Oh.
But that is why trig is sexy, because there are multiple forms of the exact same thing. right? Sine secant squared is the exact same as what I have here, which is the exact same as sine over cosine squared, which is the exact same as I can come up with several other different ones. You could say it's the same thing as secant times the square root of 1 minus secant squared. No, secant squared minus 1, sorry. Because 1 plus tangent squared is secant squared. So you could also say it's that. Which is the square root of secant squared minus secant cubed. I'm sorry, secant to the fourth.
Oh my God.
So all different forms of the same bloody thing.
You're British for a second.
Oh, and you can get really creative and then go, oh, that's all times 1. And 1 is sine squared plus cosine squared, so I can just multiply by sine squared plus cosine squared. Get really crazy. Y sine of x, find the fourth derivative. Let's start going. What is the derivative of sine? What is the derivative of cosine?
Budget.
What is the derivative of negative sine? What is the derivative of negative cosine? Oh my goodness.
So in parentheses, the fourth.
Yes, that means fourth derivative. That's just why that's taken. That's interesting. What's the 99th derivative?
Negative cos?
Negative cosine. 99 is 3 mod 4. Well, that could be something I throw on the test to try and trick you. Equation for the line tangent to the curve of cosine of x at the point x equals pi over 3. First thing we need is the slope, right? How do you determine slope? What's y prime?
Minus sign.
What is the sine of pi over 3?
Root 3 over 2.
There's our slope. Now we need the intercept. Remember that derivation we did? That would be the intercept. But y is cosine, right? Y prime, we already said, was negative root 3 over 2. What is cosine of pi over 3?
1 half.
There's your intercept. intertangent line. Easy, right? Good. That's boring. Chain rule.
Let's Pascal's triangle.
You could. I mean, you could expand that out. So look, big picture. What kind of function are we dealing with? Big picture.
Power.
It's a power function, right? What does the power rule say?
Bring it down,
Bring what down?
bring the 7 down, minus it by 1. So,
Now go one step in.
Then you take the derivative of what's inside.
So what's inside? The 3x squared minus 5. What kind of function is that?
A power function as well, right? Or a difference.
This is a difference. This is where I would go polynomial. Because derivative of polynomial is really simple. But it would be a difference, right? So you use difference rule. You want to look at each term individually. X squared minus 5. Well, 7 times 6. There's your derivative. Here's how I kind of look at it. I know it's a power function. I know what the derivative inside is. So I would have multiplied the 6x out in front. I would have done that derivative first. That's how I work. I start from the inside and I work my way out. Sine of 4x minus 1. Look big picture. What kind of function are we dealing with? What does the sine rule tell us?
Or using the special sign rule.
Well, I always default down to the general rules. I'm just going to load on my camera. That probably means the battery's about to die. I'll just keep going until it doesn't. I'll replace the battery.
Oh, that's a hero function.
Yeah.
Because I wasn't expecting to pop up. U prime times cosine of u. That is the general sine rule. But in general, it's just cosine of the function, and then you work your way in. What is the derivative of 4x minus 1?
4.
There's your derivative. What kind of function are we dealing with? Power rule says what? Bring what down?
Bring the exponent to the front and keep this exponent at 1.
So it'd be what? 4.
Or that makes 2.
Now work your way in. What kind of function are you dealing with? What does the cosine rule say? What's the derivative of cosine? Work your way in. What's the derivative of 3x? There's your derivative. People said calculus was hard. Do this all day. I can do this all day. What kind of function are we dealing with?
Power function as to the
What's the power?
half.
So power rule. Move in. What's the derivative? Now simplify. Remember, generally keep it in the same form. And your derivative. Kind of function.
Power
So how do you want to write it?
to the -3. But you could call it a quotient function, but it's like not.
You could do quotient rule, or you could do power rule. Right? Doesn't actually matter. One is algebraic. Actually, both pretty algebraic and simple. What does the power rule say?
Write down decrease, decrease.
So it's going to be what? -3 times the function. What's the new power? -4. Times what? Simplify. There's your derivative. What kind of function are we dealing with? So what does the product rule say?
Derivative of first times second, derivative of second times first.
What is the first function?
X squared,
What is its derivative?
2x.
Second function.
Sine x squared.
What kind of function is that?
Sine.
What does the sine rule say?
Close.
Yep.
Cosine.
What's the inner function?
That's
What kind of function is that?
power.
So what is its derivative?
2x.
Now simplify. There's its derivative. kind of function? What does the quotient rule say?
Bottom times derivative of top.
What kind of function is the top?
Sine function.
What does the sine rule say?
Cosine
What's inside?
find that.
What kind of function is that? Scalar multiple. And it's a scalar times a function, which has 5 times the derivative of the function, which is a power function. What's that derivative? Keep going for quotient rule.
Times 3x. Oh, no. Minus 3x times sine 5x. Or no.
You're not incorrect, but break it
3x
down further.
squared. Right?
Break it down further. Top, right?
Yeah.
Times derivative of the bottom.
Yeah. 3x squared.
What kind of function is the denominator?
Power.
Technically, it's a sum.
Oh, yeah.
Right, so then just go term by term. So derivative is 3x squared. And then all over what?
3x plus 1 squared. 3 x cubed plus 1 squared. All that squared.
Now simplify. No, bastard. How much do I want to simplify? That's the real question. I see no point in distributing. It's not gonna make things any nicer, right? So to that. We need the derivative, right? What is our derivative?
Negative 2 times negative sine x parentheses 2x minus 1.
That?
Yeah.
What is sine of 1?
0.
That's a good.
It's a trick question. Sine of 1. Sine of 1 is sine of 1. Doesn't have a nice explicit form. So just leave it. What's y evaluated at 1? Cosine what? Does that have a nice form? Hmm?
No, wait, never mind. I'm thinking cosine of 0 and 1 to be in.
Does cosine of 1 have a nice form?
Cosine of 1, cosine 1.
Doesn't have a nice form. Stays like that. So our intercept rather, will be that. So we get what? Negative 2x sine of 1 plus cosine of 1 plus 2 sine of 1. How's our tangent? Oh my. Okay. Okay, well, while that's coming up, bring this up for now. Oh, second group assignment is up.
Midterms next week.
Oh, yes, and the midterm is next week,
What does that mean?
That's new.
which is always exciting. Next week's the 7th week. That's the halfway point.
That is way
We've
too
been doing this
fast.
for 7 weeks.
Technically 5. This is the 6th week, next week is the 7th.
I should just started.
So midterm will be next Thursday in class.
How many questions?
I don't remember. We have 100 minutes, no more than 10.
And this study guide also, when is the study guide?
I probably won't post that till next week,
Like Tuesday night?
probably.
Okay,
And did-
no,
No,
it's
no.
not have to.
You can't use a computer, just your calculator.
And then did we already cover everything that's going to be on it?
No. It's going to cover, the midterm will cover everything that we do up to and including next Tuesday.
Okay.
Forgot.
Yay! Hey, why don't you give me implicit? I haven't covered implicit differentiation yet. Ooh, oh yeah, oh yeah. Okay, I like these. Oh yes, these are sexy. I'm gonna start with, I think, this one. This is the sexiest looking one in the bunch.
Oh my gosh, I'm literally gonna do this.
So again, just start on the outside, work your way in, just take it one piece at a time. Overall, what's the function? It's a square root, right?
17.
So 1/2.
So 1/2 times the function, so minus half, right? Now go in. What kind of function is inside the radical? Sum, so use the sum rule, which says what? Term by term, right? What's the derivative of 1? Okay, well that was easy. Plus, what's that second function?
Power.
It's a power function, right?
Bring down.
So power function says to do what?
Bring down the power.
So it's going to be 2 times the function raised to the first power. Now go in again. What's the function that's being raised to a power? So cosine rule says what?
Negative sign.
What kind of function are you taking the sine of?
Different.
Difference, so term by term. What's the derivative for x? What's the derivative of pi?
0.
Now simplify. That was the calculus step. Everything else is algebra. Let's see.
The more nested terms you have, the more things you multiply.
So you have a 2 over 2. That's nice. We have a negative to worry about, right? And a 4. And that's going to go in the denominator. So it looks like what? Negative 4 cosine times sine. And we're back. I think that's that, right? Negative 4 cosine sine. All over.
Square root of 1 plus 2.
I love how the chain rule just makes me like the entire original equation somewhere. So
Oh, by the way. That can be simplified.
How is it? 1 up?
figure it out. 1 plus cosine squared sine squared sine, right?
1 minus cosine squared would be sine squared.
Oh, okay.
The double angle identity for sine. Sine 2x is 2 sine x cosine x. So 2 cosine sine would be sine 2x. So there you go. That would be simplified. Oh yes, that one was fun. These are the kind of derivatives I can do all day, every day. But wait, there's more. I like this one too. Oops. What kind of function is it?
Power.
So power function. Power rule says what are you taking the power of? What's the tangent rule?
Secant squared.
But what are you taking the tangent of?
Product.
What does the product rule say?
X times G plus 2 prime.
What is the derivative of x squared? What is the derivative of cosine? Now simplify. How deep do I want to go? How deep do I want to go? Do it this way. So 6x. Oh, wait a minute. No, I can't do that. Ah, okay. Yeah, so. Oh dear. I think I'm just going to leave it like that. We'll do one thing. We'll just factor out that x. I could replace secant squared with 1 plus tangent squared. Or I could replace tangent squared with secant squared minus 1. And write that all in terms of either secant or tangent. Is that really going to benefit me? Probably not. That looks good. Oh, that's annoying. Ah, makes no sense. Crop. Yes. You really won't let me crop that any further. Oh, you suck. Will I be able to crop it here? Yes, I can. Let's do some inception type BS. Sine of a sine. Because why not?
Wait, is there no mathematical term for sine of sine? No, like second order sine or something?
It's a nested sine. What's the type of function?
Sine.
So what's the sine rule say? What are you taking the sine of?
Sine of 2x.
And what's the sine rule say? What are you taking the sine of?
2, well, 2x, and then
So it's derivative.
2.
Derivative.
Hey, how is there another cosine? On the outside of the parentheses, I thought it was just 2 cosine 2x sine x. Sine 2x.
You're taking the sine of sine.
Cosine.
Right, so derivative of sine is cosine. So it's cosine of the function
Oh, got it.
times the derivative of the function. Actually didn't. One of my favorites, so you know what? It's actually one of my favorite examples to do with the chain rule. What's y prime?
It's a power rule.
So let's start with that.
1 half.
1/6 x over.
That needs to be put on the scale. Then you have sum, right? 1 plus, oh no, what kind of function is that?
Power rule.
And what were you taking the square root of? 1 plus root x, right? What is its derivative? There's the calculus. No, the algebra.
Wait, why isn't the x on the far side have a 1/2 x? Negative 1/2?
It should be 1/2 there. I'm going to start by writing it this way instead. So I'm going to start. And then let's now do the distributions. Start with the inside. Distribute that through. We get what? 1 over 2 root x root of x plus root x. Plus, what is it? 1 over 4 root x times root of x plus root x. All right. Now distribute that other one through. Plus now that product, right, over the second term. Yes. And then what, 1/8? It's going to be an 8 in the denominator, and then something that looks really, really, really hideous. I have no idea how long you can leave it, but. That's the common denominator, right? Yeah. Got a 1. Plus, what do I need here? 2 root x for the second term.
Yeah.
And what do I need for the first term?
Over root x.
Oh, I didn't need that much. Okay. So that'll be fully simplified?
Yeah.
Now, what's that doing in real life? Like, what's that realistically doing?
Oh, who cares? It's a cool function. That's all we care about. This is a math class. We don't care what it's used for. It just looks cool. So let's do it.
What's the original function again?
A triple nested square root sum. So I could challenge you now to do
It just looks like a square root.
a fourth one. Right, so add a fourth one in there.
I mean, you could just take the answer and then change it slightly without having to do paperwork. It also
Yes, I could answer something like that. Or as we nest, just keep increasing the index powers of 2, right? The square root of x plus 4th root of x plus 8th root of x plus 16th root of x. So we can do some really crazy things now that we have chain.
Still no exponentials.
Not yet. That is Thursday. And so I'll bring that back up. The second group assignment is up. Or it's actually been up, right? You can now actually probably do just about all of it. Right, so you can derive the inverse derivative, right? Derivative of an inverse function. You can now do that you have chain rule. And I'm pretty sure most of the functions it's going to ask you to do are inverses of known functions that we've covered. I think there's only a few that are exponential and logarithmic that I have yet to do. And I don't think there's any, no, there's no inverse trig, so we don't have to worry about that one.
All right, this is probably not going to be covered in the course, but I'm just wondering. Derivatives of tetration. Is that even like a thing people know how to do?
So I haven't actually studied tetration, so I'm not familiar with it.
Huh.
So that should answer your question. It's definitely not going to be covered in this course. That is probably going to be a more advanced. What is tetration? What is tetration?
It's like the next hyperoperation after exponentiation. It's like repeated exponentiation, at least when it's done.
What do you mean repeated exponentiation?
You know how exponentiation is like repeated multiplication? Like 5 cubed is 5 times 5 times 5.
Yeah.
5 up arrow 3 would be 5 to the 5 to the 5. And you about right. And power towers are evaluated from the top down.
Oh, you could do that with this material.
Okay.
You could definitely do that with this material once I get there. Because that's just going to be an application chain.
Okay.
Plus, so for instance, we will study derivatives of functions of the form f of x to the g of x.
Huh.
And it sounds like tetration is essentially just an application of that.
Okay.
So, yeah, you'd be able to do it in this course. Do I study it actually just of that? I don't think so, but you could do it.
Cool.
So you have 2 homeworks from today's class, right? Because this was technically 2 sections. 3.5 was just trigonometric functions. 3.6 was the chain rule. Right, so I like to study them together because just trig functions is boring. It gets more interesting when you start to look at chain rule.
Are we gonna have a sheet for the trig derivatives?
Nope.
No, so we have to memorize.
You don't have to memorize them.
Oh, okay.
You have that reference sheet, right?
Oh, true.
Oh, I thought we were going to have to derive from the test.
No. You can just write them on that reference sheet.
Okay.
Again, midterm is next week. It'll be next Thursday. It will be in class. And that's all that we're going to be doing on Thursday. You only have then a week and a half. Yeah, about a week and a half left to prepare your reference sheet. So you want to get on that. Keep in mind the unit circle, that kind of stuff, the basic functions and the revered precalculus tables that I gave. I will print those out and include them with the exam. So you don't need to put any of that on the reference sheet. That will be provided for you. What we'll do for the rest of today is dedicate to group work. So however you want to do it. Get in your groups.
Thank you.